Well, welcome everybody. It's a pleasure to be here this morning and to speak to you. Just for your information, it's my first web broadcast, so if I fumble a bit, well, I hope you'll excuse me. But it's nice to be able to present to you all. I know there's quite a few people logged in. I'll be assisted here with questions from Brianna Holm, and she'll announce the questions as they are appropriate. As the announcer said, there will be a poll, only 3 or 4 polls, throughout this whole presentation. And what we're trying to accomplish here this morning is just discuss ground support, ground problems, and just to pass on some of the experience I've had and make some recommendations regarding ground support. And I'm really encouraging the audience participation, especially when we ask about your experience. So we'll get started here, and I'll go through the presentations, the slides. Plan to finish in about 40 to 45 minutes, and then we can open up for a lot of questions. The overview on this project is just to on this presentation is just to look at examples of where ground support wasn't properly applied and the result of improper application. And then some basic ground conditions, when you should put in rock support, when you shouldn't. And then some ground support matters related to geology. We're going to get started with the first poll just to see who we've got here. I'm just interested, and I'm sure you're all interested, who's logging into these web seminars and what their experience is. So if you answer the first poll, I'd appreciate it. You can see there's questions there on what's your occupation and where you are. So if you get busy and answer that, and while you're doing that, I'm going to ask Brianna to launch the first question.
Just to get a little background from you, Luck, what is your direct experience with ground support, and how often are you yourself in tunnels?
Well, I don't know if that's a little bit an impertinent question or how it is. You're my daughter, you should know that. But anyway, just for those who don't know me very well, I'm a mining engineer. I started out actually as a summer student working in mines, drilling and blasting, and then I worked for a couple of years in underground with mines in Ontario, one for the underground contractors. So I got experience, a lot of direct ground support experience and a lot of underground time at that time in my earlier years. After I started with Robbins, I worked for a while in field service, staying on job sites, and was exposed to more ground support, good ground, bad ground. And recently, of course, as I moved up through my career, I've always been interested in ground support, the interface of mechanical boring and rock. And I try to get out as often as I can in tunnels. If we have a difficult job like we have in Jinping or from projects or even Niagara, I try to go up, take a look around, talk to the owners, and actually see what's going on. So I try to get out as much as I can. I'd like to see more jobs, but it's one of my big interests in this business, in this industry. And there you can see the polls. We've got quite a few people from Europe tapped in, and we've got a good balance of designers, contractors, owners. Now we'll go into the examples of improperly applied ground support. And this first slide here, you can see that this is a Jinping project in China. This is 12.5 meters in diameter. And the specifications said ring beams, wire mesh, and rock bolts. And you can see they try to comply with that, but these ring beams in large diameter tunnels are difficult to install. And when they become point loaded, they aren't very effective. So as a result, a lot of the material falls down. You can see them in the inverse here, and it's a mess to clean up. It really slows progress. And this ground here, if properly supported with the right process, would still be in place if done properly, and much better progress. could have and would have been made if that ground support would have been done correctly. Again, the same tunnel, they're down there trying to clean up the invert after the fall, and you can just imagine trying to get that muck out of the tunnel. There's conveyors 5 meters above them, and the first muck cars 20 meters behind them. And here again, they tried to improve it on the same project, and they were using shotcrete. So they started to use shotcretes and rock bolts. But one of the problems with shotcrete when not properly applied is it masks the problem. When cracks occur or the ground starts to come loose again, you don't see it. And you can see what happened here. The shotcrete, the wire mesh, everything came down because in this case the rock bolts weren't the rock bolts weren't in the proper position. Just one sec here. Okay. Yes, the rock bolts weren't weren't the right type of rock bolts, and they should have been putting in longer rock bolts. If we look at the next one, this is down in Peru. Here they're actually down in this lower section is the top of the TBM, and they're trying to screen, and they've already had cathedraling over the top of the cutter head, and they're trying to support the ground and move forward. Of course, the right thing here is to try to prevent this cathedraling, because once you get it, it's difficult to support. It creates a lot of problems, and here that's another good example of really improper application. Same project, they're trying to four-pole, which is one of the old classic methods we deal with, caving ground over the top of the machine. But four-poling is complicated, difficult, and really, if you do your rock support correctly, there shouldn't be really a need for four-poling. Again, more four-poling. And here's another project in India, and this project is just had they ran into a fault, got flooded, and here they thought, oh well, you know, this is a double shield operating in India, about 8.5 meters in diameter. And as is classic with a lot of these double shields, the owners or the consultants specify, hey, let's put up segments that will solve all the ground problems. The ground will always be supported, and we won't have any problems. Well, you can see here, classic problem that occurs even when you've got full shielding. In this case, they ran into a fault zone. They over-excavated. There was a cathedral above the TBM, but they kept progressing. But when finally the head built up and actually collapsed the segment and flooded the tunnel. So just an example that even if you're using segments, that doesn't mean that you don't have to pay attention to ground support. Again, another shot of that tunnel after the collapse. You can see the segments up here at the top and all the debris in the tunnel. And another project in India. Here we're using a machine that was designed for 6.5 to 10 meters in diameter, and they're using it in a 6.8 meter diameter. And as a result, there was no room for probe drilling and very little room for setting up segments. And if you don't give the operators room to do probe drilling, chances are they won't do it. And this is an example of just too tight of a tunnel to do proper ground support. And here you can see what happened. The project that they were actually probe drilling, they picked up that they had this fault, all this ground silt that eventually flowed into the tunnel. They picked it up and had a packer and were trying to stop it off, but the pressure was so great that it blew the packer out and flooded the tunnel. And you can see they were trying to put up their good practices, good ring beams, wire mesh up in here. Everything was being done properly, but they ran into the fault and they didn't have enough probe drilling and packer capacity to really stop the fault from moving in on them. Another project where ground support, or really ground gave a problem, was the Niagara project. And this wasn't a case of not proper ground support. It was more of a case of contract specifications. This is a bored open tunnel and then full concrete lining as a secondary operation. But one of the criteria in the contract was there wasn't to be any loose rock behind the poured concrete. And as a result, they had to scale down all the loose rock. And this caused a lot of problems. This is the extreme case where the loose rock maxed out. It was about 3.5 to maybe 4 meters above the crown of the tunnel. And they actually scaled all this down to form the natural arch. And then they put up screening, shotcrete, and channels to keep the natural arch in place. And they're actually have to go in and pour that natural arch back in and fill up that whole space again with concrete. And that was a really problematic thing because once your rock gets in the invert, then it's difficult. Here they got a little small loader and they put in a secondary conveyor to get up to the main conveyor. And again, if you can hold rock in place, it sure helps the advance of tunneling. Why is ground support often a big problem? Well, the big problem comes because most contractors, most owners are paid for meters and just paid as you advance. You're paid for progress. So there's just a psychology. There's just a desire to get more footage. And like all of us, everybody's a little optimistic and they think, well, hey, the ground's only bad for the next meter, and if I just keep going, it's going to get better just on the other side of the next meter. And chances are it usually doesn't. So that gives a lot of problems. And so tunneling in difficult ground requires a lot of discipline. You have to be disciplined. You have to put up your rock support. You have to do your probe drilling and not always focus on meters because that ends up being short term. There's really three main types of rock support in my view. There's the occasional support that you put up as the ground changes, you put the support up. Then there's continuous support, and then there's the support you have to do for severe conditions. And that can be severe, meaning that even if you putting up segments, you still have to do some other ground support. The next poll is arriving here, and it'll come up on your screen. And Brianna's going, while you look at this, Brianna's going to field another question to me here.
You mentioned some things about main beams and double shield machines. For those that don't know, we also refer to main beam machines the same as open machines. Do you think main beam TBMs are more effective than double shield TBMs in difficult ground conditions, and why?
Well, both machines have their application. The problem with double shield machines or any type of shielded machine is that in most cases you can't visually see the rock. You don't know what's going on. So you're in effect operating blindly, and it's difficult to know how bad a ground conditions you've got. If, in my view, you can put an end beam machine or an open machine through any type of ground that you can a double shield machine. And that's a difficult question, and through this presentation, I think we'll shed some more light on that particular topic. Okay, the poll, you can see we've got some experienced people in here, so just interesting to see who's on and what your experience is. We're going to look at this occasional support matter, and we're going to look at the support matter, and one of the big problems on occasional support, what type of lining to put up for what type of ground condition. And my experience is there's a lot of time lost deciding what you should do. It's not clear. Is the owner deciding? Is the consultant deciding? Is the contractor deciding? And in a lot of projects we've seen, there's a big time loss just deciding, hey, what is the right type of support to put up here? And I'm not an advocate of letting the consultant or the contractor or